All right, so the last thing I want to do in this lesson is talk to you about how to use your EM spectrum chart in order to determine what different wave or what different type of EM wave has particular frequencies or wavelength. So in this next example, we ask what type of EM wave has a frequency of 5.5 times 10 to the hertz. If you look at your EM chart, 5.5 times 10 to the hertz, we have frequency on the bottom. And if you look right here, we have 10 to the 5, 10 to the 6, 10 to the 7, 10 to the 8, whatnot, right? We go over to 10 to the 10. Anything that has an exponent of 10 to the 10 is going to be between this level and this level. So our wave is somewhere between 10 to the 10 and 10 to the 11 because it's 5.5 times 10 to the 10. If we're looking to see what exactly type of wave it is, we'd have to look up from that point, and we see that microwaves is the only wave in this scenario that can be in the range of 5.5 times 10 to the 10 to 10 to the 11. So the answer to this first one, what type of EM wave has a frequency of 5.5 times 10 to the 10, that would be microwave. If you look at this next example, and I want to give you a chance to read your table and take a look at it. So see if you can't figure out what type of EM wave has a wavelength of 4.2 times 10 to the negative 5 meters. So I will give you a moment just to look at that, and then I'll show you the chart again, and we'll take a look and see if you did that correctly. If you're looking at this, here they're giving you a wavelength. The wavelength is at the top of the chart, and the exponent is 10 to the negative 5. So starting at the right, you're getting smaller. Here's 10 to the negative 1, 10 to the negative 2, all the way up to 10 to the negative 5. Now, anything that's 10 to the negative 5 or greater will be between 10 to the negative 5 and 10 to the negative 4. Right? So if we're looking right here, the only thing that could possibly fall around the 10 to the negative 5 is an infrared wave. So when they ask the question, what type of EM wave has a wavelength of 4.2 times 10 to the negative 5 meters, that wave would be an infrared wave. Now, this is the last slide that we have for this presentation. What I would like you to do from here, you have a CASEL learning assignment that I would like you to practice on. And then in the assignment itself, you have a couple of questions under student work from a Microsoft Forms. Try both of those. That'll help you try to practice some of your EM spectrum and wave velocity examples, and then we'll touch back when I see you next week.